Deep beneath the permafrost lies a feat of engineering designed to withstand the most brutal winter conditions imaginable.
This underground sanctuary represents the pinnacle of modern thermal architecture and self-sustaining survival systems for extreme cold environments.
Constructing a habitable space in these conditions requires a radical departure from traditional building methods and material science.
The outer shell must resist immense pressure from freezing groundwater, while maintaining a stable internal thermal envelope.
Heat is harvested from the core of the Earth to provide a constant source of renewable life support.
Aesthetic choices prioritize psychological comfort to counteract the isolation and darkness of a 6-month-long Arctic night.
Advanced insulation layers ensure that minimal energy is lost to the surrounding ice during the peak of winter.
The airlock system prevents the entry of lethal cold air while filtering out fine particles of windborne ice.
Self-sufficiency is achieved through high-yield indoor farming systems that provide fresh produce regardless of the external climate.
Maintaining air quality requires a complex network of scrubbers and exchangers to recycle oxygen and manage humidity levels.
Outside, temperatures drop to minus 60 degrees Celsius.
The contrast between the external lethality and internal safety is a testament to the success of underground architecture. Structural geometry is optimized to handle shifting soil and potential seismic activity caused by the freezing tectonic plates.
Redundancy is critical, with battery banks capable of powering the entire facility for several months without external input.
Water is sourced from deep aquifers and recycled with near-perfect efficiency to sustain the bunker's permanent population.
Spaces are designed to foster social interaction, preventing the psychological effects of long-term subterranean confinement and isolation.
External sensors provide the only link to the surface world, monitoring the environment for changes in storm patterns.
Circadian lighting and visual simulations help maintain biological rhythms in the absence of natural sunlight during the winter.
Building this structure required removing thousands of tons of frozen earth, using specialized heavy machinery and thermal drills.
The entrance is the most vulnerable point, engineered to be both airtight and resistant to extreme physical force.
Physical health is maintained through rigorous exercise programs designed to combat the sedentary nature of underground living conditions. A secondary mission of the facility is the preservation of biological diversity in the event of global catastrophe.
Computing power is essential for managing the complex life support systems that keep the bunker's inhabitants alive daily. Manual overrides are integrated into every automated system to ensure survival during potential electronic or software failures.
Comprehensive medical facilities are necessary when the nearest hospital is located thousands of kilometers away across ice fields.
Thermal signatures are non-existent from the surface, proving the extreme efficiency of the vacuum-sealed insulation systems.
Constant monitoring of the closed-loop ecosystem ensures that no contaminants compromise the air or water supply integrity.
Low-tech entertainment options are provided to reduce screen fatigue and encourage traditional cognitive engagement among the residents.
While solar energy is used during summer, the facility must transition entirely to geothermal power during winter.
Reserve oxygen tanks provide a fail-safe in the event that the primary air scrubbing system becomes inoperable.
The radial design allows for efficient movement between sectors while isolating different zones in case of emergencies.
Exhaust systems are carefully managed to prevent ice buildup from blocking the release of carbon dioxide gases.
Life inside is remarkably normal, a stark contrast to the chaotic and lethal weather patterns occurring above.
Food preparation is streamlined to minimize waste and energy consumption, utilizing the most efficient modern cooking technology.
Automated patrols monitor the structural integrity of the surface entrance and clear snow from critical sensor arrays. The foundation is anchored deep into the bedrock to prevent shifting during seasonal freeze and thaw cycles. Every resident is trained in the use of specialized gear required for the rare necessity of surface.
Precision instruments are the lifeblood of the bunker, providing the data needed to keep all systems balanced.
Ultraviolet sterilization ensures that every drop of water is free from pathogens before it reaches the tap.
As the sun disappears, the bunker becomes a self-contained world, isolated from the rest of the planet. Strategic reserves of non-perishable food items are maintained to support the residents for up to 5 years. On-site manufacturing capabilities allow for the immediate replacement of broken parts without waiting for external supply shipments. Automated lighting systems mimic the natural progression of day and night to stabilize the inhabitants' internal clocks.
Preventative maintenance is a daily requirement to ensure that no part of the life support system fails.
Data-driven agriculture ensures that the caloric needs of every resident are met with maximum efficiency and quality. Satellite links remain the only connection to the outside world, providing internet and essential global news updates.
Sanitation is prioritized to prevent the spread of illness within the confined and recycled air environment.
Hydrogen fuel cells serve as a tertiary power source for critical systems in case of geothermal failure.
Visual stimuli from the outside world are integrated into the architecture to prevent sensory deprivation during winter. The artificial intelligence managing the bunker continuously optimizes energy distribution based on real-time environmental and occupancy data.
Internal pressure is slightly higher than external pressure to ensure that any leaks result in air escaping.
Dust management is critical in a closed environment where particles can interfere with sensitive electronic and mechanical.
Reaching the necessary heat gradients required drilling kilometers into the earth, a massive undertaking for the engineers.
Fresh nutrients are essential for the long-term health of inhabitants who do not have access to sunlight.
A zero-waste philosophy is mandatory, as there is no way to dispose of trash on the surface.
Local wildlife is monitored to ensure that animals do not inadvertently damage sensitive external equipment or sensors.
Mental health is as important as physical health in an environment where the sun never truly rises.
Multiple exit points are designed into the structure to provide escape routes in case of a catastrophic.
Portable energy storage is vital for any task that requires leaving the safety of the bunker's interior.
The purity of the recycled water often exceeds that of standard municipal supplies found in modern cities.
Materials expand and contract in the cold, so the bunker must be flexible to avoid structural cracking.
Analog backups provide a final layer of safety if the digital monitoring systems were to ever fail.
Automated heaters and vents melt away snow to prevent the intake from becoming blocked during storms.
Preserving knowledge is a key function of the facility, serving as a safe haven for historical data.
Even the smallest heat leak can lead to ice formation that might jam the heavy airlock doors.
Robotic inspectors are used to maintain the hard-to-reach areas of the bunker's complex infrastructure systems.
Culinary variety is maintained to improve the morale and overall well-being of the bunker's permanent residents.
Managing energy consumption is a constant task for the automated systems to ensure no sector is overdrawing.
These cables carry the lifeblood of the facility, providing the electricity and heat needed for daily survival.
Continuous learning and professional development are encouraged to keep the inhabitants' minds active and engaged throughout.
The dome's shape is designed to allow snow to blow over it, preventing the entrance from burying.
Proper storage of medicine is vital, as the facility must remain self-reliant for all health-related needs.
Expertise in mechanical engineering is a requirement for the staff who maintain this complex underground living environment.
The scrubbers are the most critical component of the life support system, preventing toxic gas buildup.